Good afternoon. Welcome all. Welcome. Get settled. We are going to start our chemistry practice test. For those of you that were here yesterday, welcome back. Like I said yesterday, it was beautiful here in northern Indiana, which is unique this time of year. It is not quite as beautiful today, but it is warm. It's 72. No geese are honking out there yet today, but don't be surprised if you hear them. They were quite active during the webinar yesterday. I'm not sure how the sound came through on your end, but I got a little chuckle at how animated they were yesterday. So hopefully they are not a distraction to us today. We are going to dive right in and look at all the wonderful things we have available here to support your TEAS journey, and then we will kick off with our practice test. So as you know, we offer these free live webinars. You can access that QR code up there to take a look at our upcoming webinars. If you're focused on science, I have two next week, 3 p.m. Eastern Standard Time on the 12th and 3 p.m. Eastern Standard Time on the 13th. Those will be over scientific reasoning. So we'll look at all of the different components to a scientific experiment, independent variable, dependent variable. We'll focus on if you have to graph it, what goes on the x-axis, what goes on the y-axis, all that good stuff. So the 12th will be our content, and then the 13th will be our practice test, just like today and yesterday's combo. As always, remember that you can re-watch old webinars. Use that QR code and you can check those out. Those are previously recorded webinars like you've participated in yesterday and today. Yesterday, I went in great depth going over our question bank for you. Our question bank is just the most amazing thing. I love our question bank. Not only does it mimic an actual TEAS exam experience, but it also takes you to the time-stamped topic that question covers in our on-demand videos. And our on-demand videos are where we dive deeply into these subjects. So as you know, the webinars are good for content review. They're a good overview. They're a good refresher. They're also, the webinars are good to show you areas where you will want to dig deeper, and how you can then dig deeper is via our on-demand videos. So since I talked in great detail yesterday about the question bank, I wanted to talk just a little bit about the on-demand videos. So I'm going to pull those up for us to kind of talk about here. So I am in my dashboard here on our Archer website, and you can see yesterday I was in here. This is where we created our question bank. We used our test that we created. You can see that was an option there, and that's what we created yesterday afternoon. Now, today I just wanted to show you the on-demand videos. Now, you won't get to see the actual video play because of our security measures, but I just want to kind of explain how we have these broken down, because I think it is just so organized and so time efficient, and I love that. So say, for example, since we are in chemistry today, you want to review ionic bonds. We can go into that one particular section in that on-demand video to look at ionic bonds. What if you want to watch the entire video over atomic structure? You can watch the entire video. But I think that time stamping here is just one of the most amazing aspects, because it really helps you go directly to the area that you need. And we are all, pressed for time, and we like to really hone our time and our schedule. And that's one of the ways that you can do that. So I always like to show that on the on-demand videos. They're just fantastic. And I love that we have that time stamping and that we have those videos. And so it's definitely something I like to highlight before we get started. All right, I'm back to our schedule for today, other things that I would like to point out is tutoring. I have been doing a lot more tutoring and I love it, folks. As those of you who have seen me before, I used to teach in the classroom, both high school and college level. And so I really do miss that one-on-one interaction with my students. And I get that when I get to tutor. So if you're thinking about tutoring, definitely pull the plug and get started on that because I would be elated to do that for you. And speaking of tutoring, I'm going to jump ahead real quick just to talk to you about our different tutors that we have available. If you need help in English and reading, that's my friend and colleague Tammy. You can scan this QR code right here and get scheduled with her. As you know, I am Shellie Harshberger. I am your science guru, and I can take care of your biology, your anatomy and physiology, your chemistry, your scientific reasoning needs. And then Brandon, he is our math specialist. He can take care of all the math you need to know for the TEAS. So if you're in need of a tutor, get a hold of us. Those are our QR codes to get us in there. So going back here, talking about tutoring, talking about our products, we've got two packages. We've got the SurePass and the SurePass Pro. And the difference between those is that the SurePass gives you that question bank that I talked about yesterday, gives you all of our on-demand videos that I highlighted today, helps you track how you're doing, helps you set goals and objectives for where you're headed towards your TEAS exam, helps you set your schedule, all that kind of good stuff. Now, the SurePass Pro, that's where we pull in that tutoring that I was talking about. So the SurePass Pro, the difference is that you get an hour of private tutoring. So consider those when you're looking at all the different things we have available to you. And then lastly, as you know, we are all over the socials. So you can find us on Insta, you can find us on TikTok, Facebook, and you can also email us at prenursing@archerreview.com. And it's always a good time to share with you that if you go in to look for a tutoring appointment and you don't see anything that matches your schedule, go ahead and send us an email. A lot of times we can move things around and potentially meet your needs there. So keep that in mind, and we are going to get ready for our practice test with atomic structure. So we're going to go in the same order that we went in yesterday with our topics. And so we will have questions that go with these. And just to give you a general idea how this works, if you are coming at me via Zoom, put your answers in the chat box and only I can see them. That's the benefit of signing up for Zoom. You get that privacy. You can do that without question. If you are on any other social medias, everyone is going to see your responses. So just be aware of that. But please do participate. It makes it much more enjoyable for both of us. So with these questions, I will read the question, I will go through the potential answers for you, and then I will set a timer for about 40 to 45 seconds. That kind of mimics how much time you have when you're taking the actual TEAS exam. Once that time goes off, we will look at the correct answer. We will also talk about why the other responses were not the best choices. All right, without further ado, we are going to get started. What determines the identity of an element? A, number of neutrons, B, number of protons, C, number of electrons, D, atomic mass. You've got 40 seconds. Get those answers out there. All right, let's see how we did. The correct answer is B. Nicely done to those of you that had the correct answer. It is the number of protons that are in the atom's nucleus that is both the atomic number And what defines the element? Remember, yesterday we talked about if we change the number of protons, it actually changes the identity of the element. The element is no longer oxygen or nitrogen or whatever it is that we change. Now let's look at our other answer choices. So answer A talks about the number of neutrons. Neutrons actually determine isotopes, but they don't define that element. So we can change our neutron number and we can get an isotope, a variation of an atom or a variation of that element, but it is not what is defining that atom or element. Answer C, number of electrons. Electrons actually determine the charge. Remember, we can have positive cations or negative anions due to electrons loss or gain, but that's not going to determine the identity. If we look back at answer D, atomic mass, remember, is the sum of the protons and the neutrons, but it doesn't define the element. So well done to those of you that got that correct. We're going to take a look at our next one. Why does an atom become a negatively charged ion when it gains an electron? A, gaining an electron decreases the number of neutrons, which creates a negative charge. B, gaining an electron increases the number of protons, making the atom negative. C, electrons have no charge, but gaining one disrupts the atom's neutrality. Or D, electrons have a negative charge, so gaining one increases the overall negative charge of the atom. Let's get those answers out there. Hey, hopefully you chose answer D, which I think many people did. So very nicely done. So remember that atoms are made of protons, which are positive, neutrons neutral, electrons negative. So if we gain an electron, it's increasing the number of negatively charged particles. And this results in a net negative charge. And so that's forming that negatively charged ion. So let's take a look at our other answers. A, gaining an electron decreases the number of neutrons, which creates a negative charge. What's wrong with this one here is this statement decreases the number of neutrons. If you gain an electron, that has zero impact on the number of neutrons, and that's what's wrong with that. Let's take a look at letter B. Gaining an electron increases the number of protons, making the atom negative. Again, gaining an electron has no impact on the number of protons. Those protons are going to stay the same. We're gaining an electron, and it does not impact the protons. All right, C, electrons have no charge, but gaining one disrupts the atom's neutrality. Well, we know that electrons have a negative charge, protons have a positive charge, and neutrons have a neutral charge. So this first part of that response is what's wrong with it. Well done, you guys are doing great. Let's take a look at our next question. The image to the right here represents the element oxygen from the periodic table. What do the numbers 8 and 16 represent? A, 8 represents the number of neutrons and 16 represents the number of protons in an oxygen atom. B, 8 represents the atomic number and 16 represents the atomic mass. C, 8 represents the number of electrons in an oxygen ion and 16 represents the number of protons in an oxygen atom. D, 8 represents the atomic mass and 16 represents the atomic number. Get those answers out there. For those of you that chose answer B, well done. So 8 is the atomic number. That's the number up in the left. And that's representing the number of protons, the defining characteristic of that atom or that element. Number 16, remember, that's what's here, is the atomic mass. That is going to be the sum of the protons and the neutrons. And in that case, it's approximately 16. All right, so let's take a look at our other answer choices. A, 8 represents the number of neutrons and 16 represents the number of protons in the oxygen atom. Well, we can see there's a lot wrong with that, right? 8 is representing our protons, not our neutrons. And 16 is representing the sum of the protons, neutrons, not just protons. So that's what's wrong with that. Let's take a look at C. 8 represents the number of electrons in an oxygen atom. No, an electron's weight is actually so minuscule that they don't really consider it part of the atomic mass, even for the most part. 16 represents the number of protons in the oxygen atom. No, we know that that is standing for the atomic mass. Looking at number 8, 8 represents the atomic mass, 16 represents the atomic number. They just switched those two. So 8 is our atomic number, 16 is our atomic mass. Okay. Let's take a look and see what our next one is. Physical properties and changes of matter is our next topic. Which of the following statements are true about the physical properties of matter? Select all that apply. A, mass measures the amount of matter in an object or substance. B, volume measures the amount of space an object or substance occupies. C, density is determined by multiplying mass by volume. Or D, density is calculated by dividing mass by volume. Get those answers out there. Now, I often have people tell me that these select all that applies are highly annoying, and I respect that. But what I understand is that in the select all that apply on TEAS, if you get one, you get the whole problem incorrectly. You have to get all of them in order to get the problem right. So they're definitely worth addressing in these webinars. So let's look at our correct answers. Our correct answers for those of you that had this are A, B, and D. Okay. So mass is that physical property that's measuring the amount of matter that's in an object or substance. And it's going to remain constant unless something is added to it or removed from it. B, remember that's volume, and it's referring to the amount of space something takes up. And that is typically measured in liters or cubic centimeters. D is where we put it all together. Density is going to be the ratio of mass to volume. So it's calculated using mass divided by volume. That's how we get to density. Okay. So what was wrong with C? Simply that we don't multiply mass by volume, but we divide mass by volume. That was the difference there. And someone commented, thank you for the support. Someone said that these select all applies help us go deeper. And you are so right. And since you're not getting partial credit if you miss, a chunk of this on the TEAS, you certainly want to practice and get all of the correct ones right. So thank you for that. Let's take a look at our next one. Which of the following statements correctly describe the states of matter? Select all that apply. A, solids have tightly packed particles that vibrate in place and have a definite shape and volume. B, Liquids have a definite shape and volume because their particles are loosely packed and slide past each other. C, gases have particles that are far apart, move rapidly, and have no definite shape or volume. D, liquids take the shape of their container, but maintain a definite volume. Get those answers out there. Our correct answers A, C, D. And many of you are doing so great. I'm so impressed. Thank you for that. So A, yes. So remember that solids have tightly packed particles that stay in place and then they vibrate. And that causes them to have a definite shape and volume because those particles are not moving freely. Our visual yesterday was a block of ice. Okay, for C, remember that gases have particles that are farther apart and they're moving rapidly. And that means that they don't have a definite shape, they don't have a definite volume. They will expand to fill whatever container they're in. And that's why a balloon was a great visual to think about gases. Now, for answer D, liquids. Remember yesterday that we had a glass of water as our illustration, and that's because liquids take the shape of their container, but they're going to have a definite volume because their particles are loosely packed but still held together by their intermolecular attractions. All right, so what was wrong with answer B? Liquids do not have a definite shape. They take the shape of whatever container they're in, but they do have a definite volume. So well done. You guys are knocking it out of the park today. What phase change occurs when a gas turns into a liquid? A, melting, B, freezing, C, condensation, D, sublimation. Let's see those answers. Hopefully you chose answer C, condensation. So when a gas goes from a liquid, I pulled this visual from yesterday's content. We've got our gas here. When we're going from a gas to a liquid, we undergo condensation. Okay. So answer A was melting. Now remember that melting is typically seen when we have a solid that's going to a liquid. Okay. Answer B, the choice was freezing. Now that's when we go from a liquid to a solid right here, liquid to a solid, then we'll undergo freezing. Answer D, sublimation. Now remember, we had two processes, sublimation and deposition, and these were where we kind of skip a phase. So sublimation was where we were going from a solid to a gas. Deposition is where we're going from a gas to a solid. All right, our next category, describing chemical reactions. Which of the following statements about valence electrons is true? A, valence electrons determine atoms' reactivity and ability to form bonds. B, metals tend to gain valence electrons to form negative ions or anions. C, Nonmetals tend to lose valence electrons to form positive ions, cations. Or D, atoms are most stable when they have an incomplete outer shell. Get those answers out there. Hey, our correct answer, hopefully you chose, was A. And I know many of you did. So well done. You're really doing an excellent job today. So remember that valence electrons are the electrons in the outermost shell of the atom, and they are responsible for the bonding behavior of that atom and how reactive it is. So they're going to interact with one another by sharing valence electrons, losing them, or gaining them. And they do this to achieve a stable electron configuration. Okay. And what that looks like is typically resembling noble gases. So what was wrong with answer B? Well, metals do not gain valence electrons. Remember that metals typically have very few electrons in that outer shell. So they have a tendency to give up those electrons a little easier and become cations, become positive ions. Examples of this are sodium, potassium, things like that. Answer C. Nonmetals have a tendency to actually hold on pretty tightly to their valence electrons because they're generally pretty close to full. They might have 6 of the 8 in their outer shell, or they might have 7 of the 8 in their outer shell. And so they have a tendency to gain an electron, forming those negative ions or anions. Fluorine, chlorine, those are examples of those. Answer D, atoms are most stable when they have a full electron shell, not an incomplete one. They, for lack of a better way of saying this, they want all 8 in their outer shell. Remember that the first shell is 2 electrons, and every shell after that has a maximum of 8, and they really want to have that 8. And so that's what makes them more stable. So well done. You guys are all doing a fantastic job today. I don't know if I've ever seen so many correct answers. So pat yourselves on the back. Your chemistry is going to be stellar on the TEAS. Well done, you. All right, let's take a look at this next one. Which of the following statements correctly differentiate between ionic and covalent bonds? Select all that apply. A. Ionic bonds occur when one atom loses electrons and another gains electrons, while covalent bonds form when atoms share electrons. B. Covalent bonds typically form between a metal and a nonmetal, whereas ionic bonds usually occur between two nonmetals. C. Ionic bonds involve the attraction between oppositely charged ions, whereas covalent bonds involve sharing electron pairs. Or D. Covalent bonds can create polar molecules due to unequal electron sharing, whereas ionic bonds result from complete electron transfer. Get those answers out there. All right, this is one of those challenging. Select all that apply. Let's see how we did. A, C, and D. so let's break these down. So let's look back first at A. Ionic bonds occur when one atom loses electrons and another gains electrons, while covalent bonds form when atoms share electrons. All true. So remember, ionic is when one atom is going to lose an electron and become a positively charged cation, and another atom is going to gain electrons and become a negatively charged anion. Where covalent bonds, they share. Covalent bonds, neither one of them wants to give up their electrons, so they share those electrons. All right, skipping to our next correct answer, C, ionic bonds involve the attraction between oppositely charged ions, whereas covalent bonds involve sharing electron pairs. Absolutely. So ionic bonds rely on that electrostatic attraction ion, whereas covalent bonds, let's just share. Taking a look at answer D, then, our next correct one, covalent bonds create polar molecules due to unequal electron sharing, whereas ionic bonds result from complete electron transfer. That is correct. So covalent bonds don't always form polar molecules, but they can. And we talked about what a polar molecule was yesterday when we looked at water, okay? Where ionic bonds are going to be a complete transfer. We're going to get those fully charged ions, positive cation, negative anion. All right, let's take a look at our next one. Which of the following equations is balanced? And I won't even try to read these to you, but I am going to give you a little bit more time. I think it would be very beneficial to give you a little bit more time to figure this out. Feel free to use scratch paper, and then we will talk about it. Get those answers out there. All right, let's see how we did on this one. All right, if you chose answer B, you were correct. Okay, so let's take a look at how this is broken down. So notice that we have 2 nitrogen on our reactant side, 2 nitrogen on our product side. We have 3 times 2, we have 6 hydrogen on our reactant side, 2 times 3 is 6 hydrogen on our product side. Okay, so that's how we got to that. So what's wrong with our other ones? Well, let's look back at them. If we look at A, we have 2 hydrogen on our reactants, 2 hydrogen on our product. That's good. But look at our oxygen. We have 2 oxygen on our reactant side, but only 1 oxygen on our product side. Okay, let's take a look at C. We have 3 carbons on our left. We have 3 carbons on our right. So far, so good. We have 8 hydrogens on our left. We have 4 times 2, 8 hydrogens on our right. We have 2 oxygens on our left. Oh, looky here. 4 times, we have 4 oxygens on our right. That's what's wrong with that one. Let's take a look at D. We have 1 aluminum on our left. We have 2 aluminums on our right. We have 2 oxygens on our left. We have 3 oxygens on our right. So those don't align up either. Okay, so that's the deal there. Remember, sometimes that really is just a game of play. You just got to kind of play with those numbers to see how you're going to get it to balance on either side. Now, I did have a question. A question was, when will a covalent bond end up with like a polar, become a polar molecule or a nonpolar molecule? And I'll start with polar in the sense that it's when we have atoms that are bonding that one is much more electronegative than the other, or the other one is less electronegative. So it's uneven pull on those electrons. That's what causes a polar molecule. Like we talked about with water yesterday, oxygen has such a stronger affinity for the single electron that hydrogen has that it pulls that electron to it and it causes that unevenness. Okay. All right, let's take a look at our next question. Conditions affecting chemical reactions. How does increasing the concentration of reactants affect the rate of a chemical reaction? A, it decreases the reaction rate by reducing the number of collisions between molecules. B, it increases the reaction rate by providing more reactant particles for collisions. C, it has no effect on the reaction rate because concentration does not impact molecular interactions. Or D, it stops the reaction by overwhelming the reactants with too many particles. Let's see how we're doing. Okay, let's see how we did on this one. Our correct answer was B. So if we increase the concentration of the reactants, we're going to have more particles in that spot, and that's going to lead to more collisions. And anytime there's more collisions, we have more reaction. And so that is going to have a speeding up impact on the reaction. Let's look at our other answer choices. So A says it decreases the reaction rate by reducing the number of collisions between molecules. That is the complete opposite of it. We're putting more particles in that solution. There's going to be more chance for bumping into one another. So it's the complete opposite of that. All right, let's look at C. It has no effect on the reaction rate because concentration does not impact molecular interactions. No, we know that the more collisions, the faster the reaction is going to occur. And then D, it stops the reaction by overwhelming the reactants with too many particles. No, it simply just speeds it up. Okay. I had a question. I'm not fully sure I know fully what they were asking, so I'm gonna put this out there, and if this doesn't quite answer your question, feel free to ask again. Someone asked me what C3 is called as an atom, and that would be like a tricarbon. But in the context that we had it in an equation, C3H8. So I don't know if that's what you were looking for. So feel free to ask again if that's what you were going for. All right, our next question. What role does a catalyst play in a chemical reaction? A catalyst is consumed during the reaction and must be replaced for the reaction to continue. B, a catalyst slows down the reaction by reducing the number of successful collisions between reactant molecules. C, a catalyst increases the energy of reactants, making the reaction spontaneous without activation energy. Or D, a catalyst speeds up the reaction by lowering the activation energy required for the reaction to occur. Get those answers out there. All right, let's see how we did. Our correct answer is D. Okay, so let's take a look at what that was. A catalyst speeds up the reaction by lowering the activation energy required for that reaction to occur. Okay, so that was our correct answer. So it's going to speed up the chemical reaction by lowering the activation energy. And it does this really by providing an alternate reaction pathway, and that allows more reactant molecules to undergo those collisions successfully, making the reaction occur faster without being consumed. And that's what's wrong with answer A. Answer A starts with a catalyst is consumed during the reaction. Remember that biologically, a catalyst and an enzyme are the same thing essentially. And enzymes and catalysts speed up reactions and they are not consumed, which is what makes them so valuable. They can go on to foster other chemical reactions without any issue, without being used up. All right, answer B. A catalyst slows down the reaction. No, a catalyst speeds up the reaction. We probably wouldn't want a catalyst biologically if it was slowing things down. All right, and then C, a catalyst increases the energy of reactants, making the reaction spontaneous. No, we still need activation energy. So they're not going to increase the energy of the reactants. They're not going to eliminate the need for the activation energy. They're simply going to lower the amount of activation energy needed for that reaction to take place. Okay, so I did have a follow-up support to the question earlier. Someone wanted to know what C3H8 was, not just C3, and that makes much more sense. And I believe that stands for propane. So that's hopefully answered your question. All right, let's take a look at our next question. According to Le Chatelier's principle, how will a chemical system at equilibrium respond if more reactant is added? A, the system will shift toward the products to reestablish equilibrium. B, the system will shift toward the reactants to consume the excess reactant. C, the system will remain unchanged because equilibrium is not affected by concentration changes. Or D, the system will stop reacting entirely since equilibrium has already been established. Let's see how we do on this one. Hopefully you chose answer A, and I did see an awful lot of A's out there, so well done. So Le Chatelier principle is letting us know that of a stress, so a change in concentration, temperature, pressure is applied to the system while it's in restore equilibrium. If more reactant, use up the excess reactant and establish that equilibrium. I just honestly, guys, think of a teeter-totter. And we want to restore balance. So if we put more in the reactant side, it's going to shift to the product side. If we put more on the product side, it's going to shift to the reactant side. And that way we can get back to that equilibrium. All right, so let's take a look at our other answer choices. B, the system will shift toward the reactants to consume the excess reactant. No, what's happening here is the shift wants to, or the system wants to shift towards where it causes the imbalance to balance it back out. Okay, that's the idea there. We want to get back to balance. Answer C, equilibrium is definitely affected by concentration changes. Okay, we talked about that yesterday. There are several things that impact equilibrium, and concentration is one of them. And then answer D, no, the reaction is not going to stop at equilibrium. Instead, they're going to continue at equal rates. We talked about that yesterday, how in an equilibrium reaction, the reactant to products going from left to right and the products or reactants going from right to left, they're still going to occur, but at an equal rate, okay? Then when that stress is applied, it's going to shift to counteract that disturbance. So keep that in mind. All right, we're going to take a look at our next one. Properties of solutions. Which of the following statements correctly differentiate between a solute and a solvent? Select all that apply. A solute is a substance that dissolves, while a solvent is a substance that does the dissolving. B, a solvent is always a liquid, while a solute can only be a solid. C, in saltwater solution, salt is a solute and water is the solvent. D, the solute is always present in a greater amount than the solvent. Let's see how we do on this one. All right, for those of you that chose A and C, which many did, well done. So the solute is the substance that's dissolved in a solution, while the solvent is a substance that's doing the dissolving. So yesterday, for example, we talked about water and our crystal light packet. So water is our solvent and our crystal light would be our solute. All right, answer C. Answer C, let's take a look at that one to make it make a little more sense. So in a saltwater solution, salt is our solute, water is the solvent. Okay, so let's take a look. What's wrong with B? What's wrong with D? So B tells us a solvent is not always a liquid, and that's true. It's generally a liquid. So if B said a solvent is generally a liquid, okay, that first part would be true. While a solute is generally a solid, that would be true. But this idea of absolutes, always and only, beware of that in questions. Always and only have a tendency to be incorrect answers as that is the case. So as this tells us here, while a solvent is typically a liquid, it can also be a gas or a solvent. I'm sorry, or a solid. Likewise, a solute isn't always a solid. It typically is, but it isn't always. It can be a gas or a liquid. You can think of, I was talking about the crystal light packets yesterday, but think about how you can buy the liquid crystal light that are drops. That would be a visual to kind of think about that the solute is still can be liquid as well. And then answer D being incorrect. Let's see, the solute is always present in greater amount than the solvent. No, first of all, be aware of those words always. Those can generally be an indicator that's not a correct answer. And then this is the flip side. Generally, the solvent is in a greater amount than the solute. Not always, but generally. So keep those in mind. All right, you guys are hanging in there, doing a great job. Let's take a look at our next one. Which type of solution contains more dissolved solute than normally possible due to an increase in temperature? Unsaturated solution, saturated solution, supersaturated solution, or a dilute solution? Let's see how we do on this one. All right, how we do? Correct answer is C. I do see a lot of correct C's out there. Well done. So remember, supersaturated is where we've added heat in order for it to be able to dissolve more solute. Okay. So remember, unsaturated was that we can actually dissolve more solute in there. Saturated means we are at the maximum amount of solute dissolved at that current temperature. Supersaturated means we've added more heat in order to saturate more. And then D, we didn't talk about yesterday, but a dilute solution is going to be where it has a really small amount of solute compared to the solvent. Okay. And so it doesn't exceed any normal solubility limit. And so I did want to point out, someone was mentioning earlier or asking about the solvent. Is the solvent always greater in a solvent solute situation? No, it is not always greater, okay? But it typically is greater. All right, you guys are doing great. Let's take a look at our next one. Which statement correctly differentiates between water's cohesive and adhesive properties? A, cohesion allows water molecules to stick to other substances, while adhesion allows them to stick to each other. B, adhesion allows water molecules to stick to other substances, while cohesion allows them to stick to each other. C, cohesion and adhesion both describe water's ability to stick solely to solid surfaces. Or D, adhesion and cohesion both describe water's resistance to temperature changes. Let's see how we do on this one. Okay, let's see how we did. Correct answer is B. And I think A and B were hard because they were the correct opposite of one another. So let's look at B. Adhesion allows water molecules to stick to other substances, while cohesion allows them to stick to each other. Okay. And A was the complete opposite. So you just need to remember that cohesion is like both water molecules showing up, sticking to each other. Adhesion, they're sticking to other things. Okay. C, cohesion and adhesion. First of all, they're different. We've identified that in B. And it's not about sticking to solid surfaces. It's about sticking to other surfaces if it's adhesion, or to molecules of water to each other if it is cohesion. For D, adhesion and cohesion, no, that does not relate to water's resistance to temperature changes. Water does resist temperature changes. That's due to its high specific heat property, but it has nothing to do with cohesion and adhesion. Okay. Somebody had a question. Why do we need to increase temperature for a super saturated solution? Basically, the solubility of the solvent will increase as temperature rises. So heat just allows it to, for lack of a better way of saying it, absorb more of that solute. So good question. Let's take a look at our next one. Osmosis is a type of passive transport. Which statement correctly describes it? A, osmosis requires energy to move water from an area of higher water concentration to an area of lower water concentration. B, osmosis is the movement of water from an area of lower water concentration to an area of higher water concentration. C, osmosis is the movement of water from an area of higher water concentration to an area of lower water concentration. D, osmosis is the movement of solute particles from an area of higher water concentration to an area of lower water concentration. All right, let's see how we do on this one. All right, if you chose answer C, well done you. So osmosis is the movement of water molecules, first of all, across that semi-permeable membrane, and it's going from an area of higher water concentration to an area of lower water concentration. So let's take a look at what's wrong with our others. A, osmosis requires energy. Right there, stop, we're done. Osmosis is part of passive transport. So as soon as it says it requires energy, that's the problem. B, osmosis is the movement of water from an area of lower to an area of higher water concentration. No, remember our visual yesterday, we talked about that. That is actually part of active transport. I had that visual of a ball at the bottom of a hill and we're trying to push it upward. That's going to require energy. That's part of active transport. That is not osmosis. D, osmosis is the movement of solute particles. There's our problem. Osmosis is solely water movement. It's all about where's the water going. So as soon as we see solute particles, we can know that that is wrong as well. You guys are hanging in there. We're getting close. We're down to our last two questions under acids and bases. Here's our first one. Which of the following best describes a basic solution? A solution with a pH less than 7 that releases hydrogen ions in water. B, a solution with a pH of exactly 7 that is neutral in nature. C, a solution with a pH greater than 7 that releases hydroxide ions in water. Or D, a solution with a pH of 0 that is the most acidic. Let's see how we do on this one. All right, let's see how we did. Our correct answer was C. Okay, a basic solution has a greater pH than 7. Okay, and it's going to release hydroxide ions. That makes it a proton acceptor. And we had examples yesterday of bleach, ammonia, soda, baking soda, I mean. We also talked about someone had asked about milk of magnesia, and milk of magnesia was like a 10.5 on our basic scale. So what was wrong with answer A? Oops, my timer went off again, my bad. What was wrong with answer A? A solution with a pH less than 7 that releases hydrogen ions? That would be an acid. So that's what was wrong with A. B, a solution with a pH of exactly 7. That is neither acid or base. That is just like pure water. That is neutral. And then D, a solution with a pH of 0 that is the most acidic. So while the pH of 0 would be the most acidic, it certainly would not be a basic solution. Also, before I go on, I had another question. You guys are asking great questions out there. The person asked if adhesion would be an example of that would be water sticking to the side of like a glass, like a drinking water glass. Absolutely. So cohesion is water molecules sticking to one another. Adhesion is water sticking to something else, sticking to the surface of a glass, sticking to our blood vessels, sticking to the capillaries in plants as they pull water up from the soil. So very good observation. All right, folks, we are on our last question. What are the products of a neutralization reaction between an acid and a base? A new acid and a base. B, only water. C, a salt and a water. D, only salt. Let's see how we do on this last one. All right, I saw a lot of correct answers out there. Very well done. So remember, a neutralization reaction is going to occur when we have an acid reacting with a base. And what happens, like in this example here with hydrochloric acid and sodium hydroxide, the hydrogen from the hydrochloric acid is going to bond with the hydroxide in the sodium hydroxide. That's going to form our water. And then the chlorine from the hydrochloric acid and the sodium are going to bond together to form that salt or sodium chloride. Okay, so that we're really just going to end up with our water and then our salt. Okay, so let's look at our other answer choices. A new acid and a base. No, a new acid and a base does not result there. And look at the name. The name can kind of give it away because it's a neutralization reaction. And in this case, we're getting neutral because we're ultimately ending up with our salt and our water. And that's water we know is a pH of 7. It's neutral. So let that neutralization reaction remind you that we're going to have a water there, and pure water is neutral. All right, answer B, only water. Well, matter cannot be created or destroyed. So what would happen to our acid and base? Where would they go if we only had water? Okay. Same thing with D, only salt. Where would the other components in that acid and base go? Where would the hydrogen go? Where would the hydroxide ion go? We have to have a place for those because matter can't be created or destroyed. You guys should be so proud of yourself. I would say that this is the most successful I have seen in the chat boxes of correct answers. So pat yourselves on the back. When it comes to chemistry, you guys are rocking out. You're doing it. So well done you. So I always like to pull these back up at the end if you want to snatch those QR codes. Also, just remember you can bundle so you can save yourself a little bit of money there. Already, I feel like we are an incredibly affordable program anyways, but this just helps give you that extra little boost. Remember, I'd love to do some tutoring with you. That gives me that one-on-one that I miss from being in the classroom. Remember, we're all over socials. You can email us if you need, TikTok, Insta, Facebook, and there are your tutors. Last but not least, if you would please take a moment and give me some feedback, I would greatly appreciate that. So I'm going to leave this up for a few minutes, but you guys have a lovely, lovely day. And remember, I have scientific reasoning coming up next week on the 12th, 3 p.m. Eastern Standard, and the 13th is the practice test, 3 p.m. Eastern Standard. You guys have a fantastic day. I'll leave that QR code up for just a little bit. Take care.